Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2022, Paper 4, Variant 2. In this lesson, we will discuss questions on gravitational field and thermal physics. We will discuss these questions in detail as always we do. So you can improve your conceptual understanding of these topics and also you can have better understanding of these questions. Let's study together. Let's improve together. In this lesson, we are talking about October-November 2022 Paper 4 Variant 2 and total time for this exam is 2 hours and total mark for this paper is 100. On second page of exam paper, you can find some data. Means values of some constants are given to you, and if you need value of any constant in your exam for some calculations, you can come back to the second page and you can find values of constant. It's very important to understand that values of constants are given to you in your exam. So if you need, you can come to this page and you can find values of constants. On next page of exam paper, you can also find some important formulae. But these formulae are not all the formulae you need for A2 physics. So it's important to remember all the formulae, or at least you need to understand how to derive formulae. So it's very important to understand how to derive formulae, because when you derive a formula, you understand the basic physics behind that. And this is one way to improve your conceptual understanding of physics. So always try to understand how to derive formulae. And in the exam, if you need any formulae and you have forgotten, or you have any doubt about that, you want to double check, is the formula you're writing, that one is right or not. So you can come to this page and you can check these given formulae. If you look at this given formulae, on one side we have these formulae, and these are only for AS physics. And here we have formulae for A2 physics. So it's very important to understand that some formulae are given to you. Before we start working on these questions, first of all, let's try to discuss a little bit about how you can improve your understanding of physics and what is the best possible way to improve your understanding of physics. The best possible way to improve your understanding of physics is your own understanding. I mean, when you study physics, how you perceive, how you try to understand this one. So this is kind of attitude you develop towards physics. So in a simple words, I can say, if you really want to understand physics, so study physics to understand physics, not to just pass your exams. So if you develop this kind of attitude, you will improve step by step, and one day you will see, oh, you have very clear understanding of physics. So when you will look at questions and when you do and when you solve questions, you will enjoy, and that will be a fun, not a burden. So study physics to understand physics. Let's start working on question 1. For question 1 part A, we need to define gravitational field. Gravitational field simply is a region of space around a mass where an other mass will experience a force. So simply we can say a region of space around a mass where an other mass will experience a force. Means the gravitational force means attractive force. So that region we call is gravitational field. But in the mark scheme, they have defined gravitational field in terms of G. They have written G is equal to F over M. So they have said they have defined simply force per unit mass. So in the mark scheme, they have written force per unit mass. Actually, this one is gravitational field. So this is gravitational field. So they have defined gravitational field strength instead of gravitational field. They are accepting this one. If you simply write down force per unit mass, in the mark scheme, they are accepting. But gravitational field, when we talk about this one, this is a region of space around a mass where an other mass will experience force. It simply means that, imagine that we have this mass, and this mass, it has gravitational field around it. So this is the gravitational field around this mass. And if we bring another mass in this region, imagine that we bring one small unit mass here. This unit mass will experience a force, and this region we call is gravitational field. So this is what you need to understand about gravitational field. For part B, it is given to us a spherical planet can be considered as a point mass at its center. On figure 1.1, draw gravitational field lines outside the planet to represent the gravitational field due to the planet. So simply we need to draw gravitational field lines around this planet, and gravitational field lines have to be perpendicular to the surface. So first of all, you can draw these 4 gravitational field lines like this. So simply we can draw these 4 gravitational field lines, and then we can draw 4 more gravitational field lines. So between them you can draw 4 more gravitational field lines like this. So this is how you need to draw this gravitational field. Now, if you go to the second part, it is given to us a satellite is in a circular orbit around the planet. So now we can imagine that there is a satellite that is in a circular orbit around this planet, and we can imagine that mass of this satellite is m, and this is orbiting around this planet. So simply you can imagine this is orbiting like this around this planet. So we need to explain with reference to your answer in B1 why the path of the satellite is circular. So in this case, we need to understand as this satellite is moving in a circular orbit, at any point the force on this satellite, if we take the velocity of this satellite this way, direction of motion of the satellite is this way, and the force on this satellite, this will be perpendicular to the velocity, and we can take this one at any point. If we take at this point, for example, the velocity of the satellite will be this way, and the force on this satellite will be this way. So always angle between force and angle between the velocity of the satellite is 90 degrees. So that's the reason this will move in a circle. So we can simply write down as in this case, force is always perpendicular to the velocity. So the force will cause centripetal acceleration. So these 2 points, if you write down, you will get 2 marks. So force will cause centripetal acceleration means only direction of motion of the satellite will change, but its speed will stay constant. So when we talk about centripetal acceleration, this is due to change in direction. So very important point you need to understand. Centripetal acceleration is due to change in direction of object. So let me show you the answer, how you can write down the answer. So this is how you can write down the answer. In your answer, you have to mention these 2 points. One, you can say in this case, field lines show force on the satellite that is towards center of the planet. I mean, this force is towards center of the planet. So you can see this is pointing to the center. This is also pointing to the center of the planet. And the second point, we can say gravitational force is perpendicular to velocity. As you can see here, the angle between force and velocity is 90, so they are perpendicular to each other. So force will cause in this case centripetal acceleration, and centripetal acceleration is due to change in direction only. So in this case, force will only change direction, but force will not change the speed. For part C, it is given to us an object rests on the surface of the earth at the equator. The radius of the earth is 6.4 times 10 to 6 meters, and we need to determine the centripetal acceleration of the object. For this question, it is given to us object is placed at equator. If object is placed at equator, it means object has centripetal acceleration, and we need to calculate value of that centripetal acceleration. So first of all, we can imagine that this is our beautiful planet, and on this planet, object is placed at the equator at this point, and our planet is rotating about its own axis. So it is rotating about this axis. So this is axis of rotation of our planet. We can little move this one. This is at the center. So you can see this is exactly at the center. So this is at the center. So it's rotating about this axis. So our planet is rotating about this axis. So this object will also do, in this case, circular motion. So we need to calculate centripetal acceleration. And we can also imagine that the radius of the planet at equator, this is, let's say this is capital R, and the value of capital R is given to us. So we can say capital R is equal to 6.4 times 10 to 6 meter. We need to calculate centripetal acceleration. Centripetal acceleration A is equal to R times omega square. But our planet complete one cycle in 24 hours. So it means the time period is 24 hours. So this is also we can write down. So when this planet will complete one cycle, it means the object at the equator, this will also complete one cycle. So the time period of this object is also 1 day, or you can say 24 hours. Now simply we need to use these informations and we need to calculate value of A, and this is the centripetal acceleration. So we can simply write down first of all omega, because we have time, so we can replace omega with time period. Omega is equal to 2 pi over t, means for one cycle when we are talking about, so it means this one has to be the time period, 2 pi over t. So we can plug in values of omega here. Now this is 2 pi over capital T, means the time period square. So we can write down here, this is R, and here we have, this is 4 pi square divided by t square. And now simply we need to plug in values. So R is given to us, that is 6.4 times 10 to 6. And 4 pi square, this is constant, you can plug in values of pi, and t square, we have 24 hours. We want our answer in meters per second, so we have to convert hours into seconds. So 1 day has 24 hours, and 1 hour has 60 minutes, and 1 minute has 60 seconds. And we need to take square of this value. And if we solve this one, in this case our final answer will be 0.034 up to 2 SF meters per second. So this is the centripetal acceleration of object at equator. And acceleration will be different. For example, if the object is placed right at this point, at the pole, centripetal acceleration will be 0, because this is always at rest. So it has no rotation. So its centripetal acceleration will be equal to 0, because it is at the axis. So these things you need to understand. If you write down this one, you will get 3 marks. So this is our final answer. For the second part, we need to describe how the two forces acting on the object give rise to centripetal acceleration. You may draw a diagram if you wish. So first of all, we can draw our beautiful planet. So this is our planet. An object in this case is placed at equator. So we can draw object. Object is placed at the equator. And there are two forces acting on this object. One is the gravitational pull, means the force between this object and the planet. So that force we can say is, this is gravitational pull, or simply you can say force of gravity. And there is a normal force acting on this one, that is away from the center. So we can say this is N. As this object is rotating in a circle, so it means that there is a resultant force on this object. So we can write down F net. And this object is moving in a circle, and net force has to be pointing towards center of the circle. So in this case, Fg has to be greater than N. So in this case, there is a resultant force, and that resultant force we call is the centripetal force. Centripetal force is just a fancy name for resultant force, and that centripetal force is equal to Fg minus N, and that will cause centripetal acceleration. So if these points are clear to you, so let me show you the answer. So this is how you can write down the answer. In your answer, you have to mention these 2 points. Gravitational force and normal contact force are in opposite directions, and their resultant force causes the centripetal acceleration. So if you write down these 2 points, you will get 2 marks. For the second question, part A, we need to define specific heat capacity. Specific heat capacity is a very simple concept. Imagine that we have a unit mass of any object. Unit mass, or simply you can understand this is 1 kg. So we have unit mass, means 1 kg. Unit mass. Let's say we place a thermometer inside this one. So you can imagine that this one is a thermometer. We place this thermometer inside this one. Let's say the initial reading of this one is 20 degrees Celsius, and we want to raise this temperature by 1 degree Celsius. So we need to supply heat. We need to give thermal energy to this one. So we need to supply heat, or simply you can say thermal energy. So we need to supply thermal energy, and this thermal energy will increase temperature of this object, this unit mass, by 1 degree Celsius, by unit change in temperature, or simply you can say by 1 degree Celsius. And that amount of thermal energy we will supply, that is called specific heat capacity. The amount of thermal energy we will supply to raise temperature by 1 degree Celsius, that amount of thermal energy is called specific heat capacity. And specific heat capacity is a quantity. So you have to define quantity in terms of quantities. So we will say unit mass, and we will say unit change in temperature. Unit change in temperature. So you have to be very precise when you define these quantity. Unit change in temperature. Unit change in temperature. So this is how you can write down the answer. You can simply say that amount of thermal energy required per unit mass to cause unit change in temperature. If you write down this one, you will get 2 marks. For part B, it is given to us a fixed mass of water in a beaker is at atmospheric pressure. The initial temperature of the water is 0 degrees Celsius. The water is supplied with thermal energy capital E so that its temperature increases to 8 degrees Celsius. There is no net change in the volume of the water. Use the first law of thermodynamics to complete table 2.1 for this process. So first thing in this case we need to understand, it is given to us there is no net change in the volume of the water. As there is no net change in the volume of the water, this simply means that work done will be equal to 0. And question is asking us to use first law of thermodynamics. So the best way to answer this problem is you can write down first of all first law of thermodynamics. Mean the change in internal energy, this is equal to amount of heat supplied or amount of heat released plus work done on the system. So this is work done on system, or simply you can say work done on gas. In this case, as there is no change in volume, volume remains constant. It means that work done is equal to 0 because work done is equal to P times delta V. So work done in this case is equal to 0. So simply we can say work done is equal to 0. And it is given to us the amount of thermal energy supplied, that is equal to E. So we can write down amount of thermal energy supplied, this is equal to E. So it simply means that delta U in this case is also equal to capital E. So work done on water in this case is 0, and the increase in internal energy in this case is also E, or simply you can say plus E. For the second part, it is given to us the water is now heated so that its temperature increases by a further 8 degrees Celsius to a final temperature of 16 degrees Celsius. The process causes the volume of the water to increase so that work W is done. Assume that the change in internal energy is the same as in part B1. Again, use first law of thermodynamics to complete table 2.2 for this process. Straightforward question. If you simply understand how to use first law of thermodynamics. So how we can use first law of thermodynamics? So simply you can write down in this case delta U, this is equal to delta Q, means amount of heat supplied, amount of thermal energy supplied, plus we have W. W is the work done on gas. Very important. So if heat is supplied, means thermal energy is added to the system, this one is positive. So if heat is added to the system, so it means delta Q you will take positive. If thermal energy is taken away from the system, means the heat is released. So we can say released. So in that case, you will take this is negative. But for this question now, it is given to us that work done, the volume of water to increase so that work W is done. So in this case, you can imagine that here we have water. So we have water inside. So you can just imagine water in this cylinder and the piston is attached here. So in this case, volume of the water is increasing. So volume of water, let's say it goes to this level. Volume of the water increase. As volume of water increase, it means work is done by water. So we can say work done by water. So if his work is done on water, water, we will take positive. And now in this case, work is done by water. So we have to take this W negative because this is work done by water. So let me write down here, work done by gas. This is equal to negative of work done on gas. So we have to take this is negative. And it is also given to us in this case, change in internal energy is the same. And in the last part, we have seen change in internal energy was plus E. And now we need to calculate what is this delta Q. So delta Q from here you can find out. This will be equal to W plus E, or you can say this will be E plus W. So simply we can say in this case, increasing internal energy is the same. So this is still E, or you can say plus A. And work done on water. So this has to be negative because work is done by water. And delta Q we have, that is plus W, and this is plus E. So this is how you need to write down your answers. For part C, use the information in B to suggest with a reason how the average specific heat capacity of water between 8 degrees Celsius and 16 degrees Celsius compares with the average value between 0 and 8 degrees Celsius. So in this case, simply you need to understand C is equal to Q over M times delta T for the same rise in temperature. In this case, we have the same amount of water and we have the same rise in temperature. We have the same mass of water, we have the same rise in temperature. But in the second case, between 8 degrees Celsius to 16 degrees Celsius, we have to supply greater amount of thermal energy. So this Q is greater in the second 8 degrees Celsius change in temperature. As Q is greater, it means when the temperature increased from 8 to 16 degrees Celsius, average specific heat capacity of the water is greater. So that one simple point you need to explain, or simply you need to write down. So Q in this case, in the second case is greater, so it means C of water in the second case is greater. So we will say more thermal energy required, so the specific heat capacity is greater. So this is how you can write down your answer. So these points you need to mention. More thermal energy required between 8 to 16 degrees Celsius. So the specific heat capacity is greater. So if you write down this one, you will get 1 mark.